Brian here from quantlabs.net. I just wanted to show you a very powerful development, more like a milestone. I'm going to show you a very primitive, well, it's actually a dummy type of what we could consider a trading model built from Simulink from scratch using Stateflow and creating a custom Matlab M functioner in the world of Simulink and Stateflow. It's really more of a an S function, as well as I'm going to show you as well the code generation in C, as well as C++ and even potential other options in FPGA for through HDL and all that. So let's get started. So I'm here in my current version of Matlab. What I have here is I've created a very basic model in Simulink. It just reads an Excel file. All this stuff is just generated from standard webinars and various things. So we have an Excel spreadsheet, it parses it, and creates these prices. Now, ultimately, this will be streamed into the model within the C, which would eventually become a DLL in a production trading platform. Obviously, a good example could be TradeLink, Deltix, or any other trading platform that can read C. It can be done on Linux. As long as it can read C, create an object file, and then that can be imported into whatever deployment trading system you want. That's why I choose C, but let me just continue on with where we're at. Okay, so we've got our test import RSI. So obviously we're trying to do an RSI type of model. So we've got our data. We're going to import it into something called Stateflow, the chart, which this is. And essentially what we're going to do is, you can see it's all visual. That's the really nice, powerful thing about it. So if you're not a programmer, you can understand the power of something like Simulink, Stateflow, and be able to generate all these trading modules visually. So what we got here is, on default, we are going to run a custom Matlab function here, which is defined by this little guy. And then depending upon the results of the output of that function, what will happen is it'll run one of these two conditions. So in our case, we're going to send in the Bund information, that Bund matrix that I just sent. We give a period of 10, and then we have a resulting output from that function, and that will get created in this RSI index. So based upon that result, if it's less than 30, we execute this state, or if it's greater than 70, we run this state. Okay, so essentially it's no different than a stupid RSI. Now, when you see this is all dummy stuff, all I really care at the end of the day is just to generate C code and be able to demonstrate that this can be done visually, can be done fairly easily once you understand the process, which is not that difficult. For my members in the quantlabs.net premium, I show them every step of the way with a 15-minute, 10-minute video. There's about 5 of them, how this is done in detail. But I'm just giving you a 35,000 foot view of this and a condensed version of that. But again, this is all visual. So again, you run as soon as you come into the Stateflow chart, and this is one of the more powerful things, is when you have data being streamed in, to be able to do this sort of thing through something like a stream base is very difficult. That's why Stateflow exists. And again, it's all done ingeniously with Matlab through this visual representation of the logic on what you want it to do. It's all event driven. It's a powerful thing about it. So again, let me just go over this again, this chart, the Stateflow chart, run this Matlab function. I'll go into this in a little bit. So we just pass the Bund argument with a period of 10 into this RSI function with the result of an RSI calculation of maybe if it's less than 30, we execute this state. If it's greater than 70, we run this state. Now we can have a default, have it do something else and all sorts of stuff, but let me just show you what the function does. essentially this function has been captured from or downloaded from another resource on MATLAB File Central. But because I'm still kind of learning Simulink and Stateflow, I'm just trying to make the process really simple. So in my case, I'm all hard coding all this stuff. If the input button is greater than, let's say, 112, let me show you what the data looks like in the workspace. As you can see, it's going to be 112.09, 0.85, sometimes it'll be 112.2 or greater than that 1.12. So that's where I get that number from. So back in the editor, where we just left off, and again, the output, the result for the RSI calc, it's going to be, if it's greater than 112, fudge it, hard code it at 29 or 71 based upon the value of the incoming Bund argument. And that's basically the function. It's so stupidly simple. It's meant not to do anything really tough or anything. But let me just show you some other capabilities of Stateflow. So I'm gonna run it now. Now again, I just want people to understand the hierarchy of this. We have the Simulink parent canvas, I guess you could call it, and then all I do is just in the chart, in the Stateflow chart, I just double click and I'm going to come into this Stateflow chart I've just been going on about. So now I'm going to run it. So again, just so people that are fairly new to everything in the world of Simulink, I've already mentioned this probably a million times. This part is the inflow. This part is the outflow. This is where your trading model will reside within Simulink. So in this case, this is how we stream the data into the model. And of course, the model is going to run, and it's going to have some kind of output, maybe a buy signal or who knows what. You can have as many of these as you want. Okay, and that is all done through the scope. And all the scope's going to really do is just going to make a signal of this buy signal. Buy signal 1, yeah, buy, sell signal, maybe set it to -1. So there's some other little details you may need to know about the Simulink, or sorry, the Stateflow chart. We have something called a model explorer. And every step of the way, when you start visually creating all these little things, all these states, let me pull out a custom function just to show you how easy it is. That's it. If you want to create a new custom function in Matlab, you just double click, brings up the editor, and boom, boom, bada bing. It's that easy. That's what I like about it. But if you went into the Model Explorer, you'll find that this new Matlab function is dynamically added right here to the Model Explorer. Okay? But if I delete it, everything's all in sync. Looks like I can't delete it for whatever reason. Yay. Okay, I'm going to delete. Yay. Okay, so if I go back to the model, it's no longer there. Or to the Model Explorer, it's no longer there. Okay, because I deleted it. Duh. Anyways, moving on. So back in the Explorer, you'll see that I've got this chart, which is really the Stateflow chart. We have two states, one called sell signal, buy signal. We have the function, which also includes some new objects, and these are the inbound and outbound arguments. So obviously it's called Bund arg, period, like here. Bund arg and period, that's the inbound. And then we have our output, which is out. Pretty simple. But we have full configuration of capabilities through this little dialog here. It's very cool. Not only that, but you can also create some really cool documentation and have it linked to a Word document or to a website or to a HTML page. So we can create some really cool stuff on the documentation side. So going back into our Stateflow, and again we're in the Model Explorer. It gets kind of confusing on how all these things move around and all the logistics, but it's fairly straightforward once you start playing with it. And then we have our condition, which I should also explain here. As you can see, this is a transition, and this little guy is associated with that transition or this transition. And these are your conditions. So if the RSI index from here is less than 30 or less than greater than 70, run one of these states. So we understand all that. Hopefully, if not, power of video, you can rewind and replay to sort of understand it. But now, if you push this little button, we can run it. So let's do that. So here's all our input, and we have a debugger built in. Now, the question is, what's the output of our scope? Nothing. Yay. That's not a good sign. Let me just show you the debugger. Okay. So here we can set breakpoints. If you're a coder, you can set breakpoints, or if you want, you can put a breakpoint in the editor. If you're fairly familiar with the code of MATLAB functions, that's what I've been doing all day, really. So if you run it, here you can see that it's going to now break here, which it's what it should be doing. You can step out, move to the next state, brings you to here. Now again, remember I told you about the Bund arg? You can see the values 111.09, which is the first element in that matrix from the Bund. Where's that Bund? Where are you? Oh no. I have to go to the workspace. Bund should be in here somewhere. Could that be our problem? Okay, no. So our Bund is equal to 111.09. Alright, well, let's just continue along. And then let's go into our editor. So here we have the Bund argument. We can go through the MATLAB function. Step out, comes out. And now it came through this condition because it's greater than 112. So it's setting this guy here to the output at 71, which it's coming into this transition right here of greater than 70. That sets a signal. Okay, so I can continue, and here's the state that it's in, and I can keep doing this to my heart's content until it's finished. Now, the question is, what's in the scope? Alright, so I've completely run the full Stateflow and the Simulink model. And what I wanted to show, here's the model. It's now complete. Usually, if you come under the history, you'll see pretty well nothing, which means it's kind of done. Anyways, this is what the scope looks like. So it set everything to that cell signal of -1, which means it shows that it's working. So we know that it's working. Great. If you want to see that again, now let me just get into my Stateflow save. I'm going to run it again. So we come in here, continue. I've shown you this before. Bund argument 112. It's going to set the out to 71. Blah blah. Here we go. It's going to set the bi-signal to -1. Now I'm just going to continue. So you hear that little ding. And if you come into the Simulink model, look at the scope. It's all -1. Yay! So it's working. Well, theoretically, it's working. So that's great. So now what we're going to do is we're going to create C++ from it through the code generator. Now I'm trying to make my life easier. There's two ways to go about this. You go to C or C++. Okay? I choose C. I like my code simple. Some people like C++. Go for it. But it's more code, extra work to understand and reverse engineer. But there's a little trick that people should know about. I just care about generating code, generate code only, and generate code. Also under the configuration, now remember I'm under configuration parameters for the code generation. Under comments, I've checked off everything. So I'm going to get comments for the Simulink, Stateflow comments, Matlab source code included, anything else. I'm just going kind of crazy just to show you all this. Okay, so go back to code generation and generate code. Now remember, I'm generating C. Okay, so now off she goes. Just generated that set of code for me. I can verify that because obviously I get a successful completion. It'll tell me where all the code resides in here, blah, blah, blah. So if I go to that file, here's what the code now looks like. This is the resulting code. Now remember, just remember the power of this. I have now visually created a Simulink model, visually created a Stateflow chart, as I've shown here, outside of this function. Okay, and then there's ways to go about creating your Stateflow function where you could do something and generate code for it. Matlab, this is called Matlab MScript, and it's fairly simple. It's not difficult, but it's very feature rich. So that's pretty well the only code, and this is where I put all my algorithms or whatever I'm doing. But with the power of all this, I am now, as I said, I'm now able to generate C or C++ code. I just showed you that. So let's take a look at the code. Check out the quality of this code. Now some may say, oh, it's bloated or anything. That's why I don't use C++. But because the name of the model is called this guy, test import RSI, that's where most of the code will reside. So what I want people to understand is that we have here this test import RSI C file, right? So let's take a look at it. We don't care. We care about the C file, so let me just pull up dumb WordPad. Now remember I showed you about all those comments? Here's some where all those comments are. This right here is from the Matlab MScript function I just showed you, which is really in the Simulink Stateflow chart, this guy. This is now also included as part of the code generation. So the reason I do that is so that I can make reference within the C to see how and where my C code matches up with what's coming out of the Matlab MScript or the Stateflow or the Simulink. So that's part of the Matlab custom function RSI, which I just showed you. Again, if I need to show you, it's this guy, which really is Stateflow, this RSI Matlab function. Cool? Awesome. Okay, so we have here all our code. It's all generated right here. Okay. Kind of looks simple, I hope. But nonetheless, now we're getting into the chart. Now remember, I'm just using the chart name or the default name of chart. Duh. Let me just show you that, just so that. See, it's called chart. Chart. This is a Stateflow chart. You blow it up, boom, it's chart. So that is this code right here, and the chart. That's it. So here in the code, you can see that we're setting that bisig, this guy right here, to equal -1 or 1, based upon that visually. Pretty simple, eh? And again, you can remove all these comments if you want. So we have a transition here, another transition. We set the these bisig data elements or Stateflow objects to -1 or 1. So that's part of the logic right there. And then we get into generating initialization code, some helper functions. And that's what we're looking at right now. So this data right here is from that Bund file, that Excel file I was trying to show you, which is really, let me just show you that. This guy right here, this is the source of all the data. This stuff, which is really the close that I'm working with. And that is that, okay? That's where that data is coming from. So that's all included. Some very powerful stuff. Now that's the entire C file. Let me go back to where I was. So this is all the C stuff. So you get a usual test import RSI C file, header file. It's pretty simple stuff. It looks bloated, but as I said, I can remove all the comments if I want to simplify it. Now, also, as I said, there's some helper functions that are part of the code generation process. Let me just go back to my Stateflow here. So when I do this code generation here, okay, and I do this generate code, what's happening is using the Matlab coder toolbox. So this function has to comply no different as if you were to code generate on its own using the Matlab coder. Okay, so be aware of that. This is probably where you'll spend the most of the time. It gets kind of hairy, but it's not too bad once you understand the process, and it's pretty simple actually. Once you get past the first one, know what to be on the lookout for when you are building these functions, MATLAB functions, to comply with the MATLAB coder. Okay, so let's get back to our directory. So again, these are supporting functions. So we have this RT non-finite. I'll just show you that. These are created from that MATLAB coder process. Here's a get infinity one. So if you're going to use the MATLAB coder, you'll get these resulting C functions regardless. MATLAB get not a number, and again you get all the supporting header files, C files, all that stuff. Okay, now you're probably asking, what does RT stand for? RT is the old product name or the old toolbox for the Simulink coder, which this is. The C plus all this is part of the C Simulink coder. That's the new toolbox, but the old name of it used to be called Real-Time Workshop. So that's what the RTW stands for. Okay. So all in all, let me just sum up what we got here. We created from scratch a model visually with a file, import a file. I can import an Excel file, a CSV. This is our model here in this Stateflow, and then we have our output, which I just showed you, and that's the outflow. But here's where all the activity happens. This is where your actual strategy takes place. We've created a MATLAB function, which I showed you with this little, just pretty well if section and if else. That's it. And then we created a representation visually on different states. Pretty simple, and now with this folder of C, I should be able to generate a DLL from it in Visual Studio, and then import it into a trading platform. I've already done that with TradeLink. I've got videos on that for my membership. Now, this is just a proof of concept. It seems to work just fine. Once you get past everything, it's fairly easy and very, very, very powerful, and you can do it very quickly. So you may be asking, what's next? Okay, so the files I include for my quantlabs.net premium members. Also, as I said earlier at the beginning, I have created about 5 videos on how to, in detail, how to debug with the set breakpoint and the resulting, and how to do that, how to create this MATLAB M function, how to create the Stateflow chart, you know, basically in detail somewhat to how to go through this Simulink model, and I give a better representation of the resulting C source code as well. But this is just, like I said, a 35,000 foot view of what can be done with Stateflow, Simulink, and the C code generation. And as I said, if you really, this is why I use Simulink. You cannot get with Python or R, not as easily. You can create, as I said, you can do all this, which I'm doing in C, C++ at the click of a button, and just regenerate new code. That easy. Now, it doesn't stop there. If I decide to go HDL, now I'm getting into a whole nother world, but if I wanted to, I could generate HDL code, which is essentially for FPGA deployment. Again, for Xilinx, Altera, and I can choose one of these resulting languages and generate the code for it. But again, that's another whole world, that's a whole other process. With the manufacturers for FPGA, it's getting tighter and tighter in those relationships with Matlab and a better integration using the Stateflow and the Simulink toolboxes. Awesome project that we got here. I just wanted to show you how fast and how I won't say easy, but to generate something from scratch without having to hand code it is very powerful, and now you can deploy it into a number of target languages, as I said, C, C++, or one of the HDL languages. Hope you enjoyed this. Join the membership. I'm going to have a live webinar on this, handling all the Q&A, all the quick demo of this, so that people can get a better handle on it. I'm going to be doing that sometime in coming week or two, but I hope you do like this. And again, these are the reasons why I do this, and it's the membership that helps fund me to put the research into this. Okay, talk to you later. And again, this can be used for HFT purposes with obviously FPGA deployment. Talk to you later.